Hello everyone, welcome to Algebra 1 Essentials Lesson 2. So this is the second of 4 lessons that we're going to have before the end of the school year. In this lesson, we're going to be comparing linear functions. So we're going to be talking about some of the key characteristics and just comparing different ways that we see it. Here are the IXL codes that you're going to be working on at the end of the lesson. For the first assignment, you're going to be comparing linear functions just for graphs and equations. In the second lesson, you're going to be doing a very similar thing, but instead of just graphs and equations, you're also going to include tables, as it says right there. The way I'm going to be grading you is going to be based off of the sum of your SMART scores. So I'm going to take both of your scores, add them up, and I'm going to give you a grade based on the table that you see right here. Anything above 150 is going to be considered extra credit. You don't have to get there, but if you really want to prove to me and to yourself that you really understand this, you will aim closer to that 150. Here's an overview of the things that we're going to be talking about in today's lesson. So like we said, comparing linear functions, graphs, and equations, that's going to be the first part of today's lesson. We're going to go over some of the basics. So we're going to review slope, y-intercept, and in some of the problems, how to find the value of y. And then we're also going to be talking about what happens when we see fractions. For the second section, when we start talking about tables, we're going to be reviewing the same things, but we're going to also talk about obviously how it's different because now we're working with tables instead of just graphs and equations. For this lesson, you will need some paper and a writing utensil. There are several things that I definitely would recommend that you take notes on, and there are some portions where you can use a calculator. I actually will recommend that you use a calculator for today's lesson. Here is example number 1. For this first one, we're just going to be focusing on graphs and equations. We are told that we have function A and function B, which are linear functions. That word linear is important. We'll talk about it more in a bit. We're told what function A is. Here we have an equation. So we have y is equal to 3x minus 3. And for function B, it's just a graph of a line. That makes sense because we are talking about linear functions. Linear functions are just equations or graphs that represent a line. If we look over to our question, we're being asked which statement is true. The first one says the slope of function A is greater than the slope of function B. And then the second option says the slope of function A is less than the slope of function B. Okay. So a few things that are important to make sure that we understand what the question is asking. Let's make sure that we underline a few things. The first thing that stands out to me is the word slope. So we're talking about the slope. So slope of function A. Okay, so we need to talk about the slope of function A right here. We're going to talk about that, and also the slope of this function, function B. And we're asking ourselves which one is greater, or in this case, which one is less. So is the slope of function A greater than the slope of function B? Or is the slope of function A less than the slope of function B? That's what we're trying to figure out. There are a few things that we need to review real quick before we could fully answer this question. So let's look at function A first. Y is equal to 3x minus 3. Do you remember the name of the equation, the way that equation is written? Do you remember that? And if you said slope-intercept form, you are correct. Yes, this is written in slope-intercept form. Y equals mx plus b. If you remember from class, you know that m stands for slope and b stands for y-intercept. That's very important for function A. Let me just rewrite that under function A. So we have y equals mx plus b. The reason that's helpful is because it's very easy to see what the slope is. Here, the slope is m, which is just a number that's being multiplied to x. So for this problem, our slope, our m, is equal to 3. So that's pretty simple for this one. M is equal to 3. We know what the slope is. Now we need to find the slope for function B. In order to find the slope for this graph for function B, we need to remember what slope means. So yes, slope is m in slope-intercept form, but slope is also the same thing as saying rate of change. And we know that that's equal to the change of y over the change of x. Rate of change, slope, They're the same thing, change of y over change of x. So to find the slope for this graph, well, we need to find 2 points first. Ideally, you want 2 points that land exactly on one of the coordinates. This is what I mean. So for example, let's look at this point. It lands perfectly on one of the intersections. And let's find another one. This one also works. For example, you could have also chosen this one down here or this one down here. There's a few options, but you could use any 2 points. A lot of us, when we talk about this type of problem, we think rise over run, and that is correct. But remember, it's the same thing as saying change of y over change of x. So I'm going to focus on these 2 points right here. Let me just circle them. All I want to do is just move from one point to the other. So if I start at my first point, let me move 1, 2, 3, 4, 5. So that's 5 units. Because I moved up, I moved in the positive direction. This is going to be a positive 5. And now that I moved up 5 units, the next thing I need to do, it looks like I need to move to the right. And I move to the right 1 unit. So now that we know that, let's look back at our definition of slope, change of y over change of x. Change of y, we know that y moves vertically, it moves up and down. So here it looks like change of y was 5, because that's how many units we moved up. Change of x, we moved 1 unit to the right, so that's in the x direction, that's side to side. So we have a change of x of 1. So 5 over 1 is our slope, but we could simplify that. 5 divided by 1 is just 5. So our slope here is 5. Let's look at the question one more time. Option 1 says the slope of function a is greater than the slope of function b. Well, let's see if that's true. The slope of function a, well, that's just 3. So the slope of function a, so 3, is greater than the slope of function b, which is 5. Okay, so is 3 greater than 5? No. 3 is not greater than 5. And because of that, the second option right here, this one must be true. The slope of function a, which is 3, is less than the slope of function b, which is 5. Yes, that is correct. 3 is less than 5. The slope of 3 of function a is less than the slope of function b, which is 5. The second choice is correct. Here's example number 2. Very similar to the first one, we have 2 functions. They're both linear functions. We have function a, which is a graph, and function b, which is an equation. But the main difference is that this time, we're being asked to compare not the slopes, but the y-intercepts. The question asks, which statement is true? The y-intercept of function a is greater than the y-intercept of function b, or the y-intercept of function a is less than the y-intercept of function b. So again, the key words for this problem are y-intercept. We see that all over. We're asking ourselves which one is greater or less. So is the y-intercept of function a greater, or is the y-intercept of function b greater? Let's start off with our equation like we did before. If we look down here at slope-intercept form, we already said that b stands for y-intercept. That's what it represents. If you look at function b, this -2 is going to be our y-intercept. That is what b represents in this case. So we know that -2 is the y-intercept of function b. Now let's find the y-intercept of function a. What we know about the word y-intercept is that it is where our graph, which is here in green, crosses the y-axis. Well, the y-axis is this line going straight up and down. So let's just figure out where the line crosses the y-axis. And it's right here. The y value right there, well, there's a -2 and -4, so this has to be a -3. So my y-intercept for function a is equal to -3. So now let's look back at the question. The first option says the y-intercept of function a is greater than the y-intercept of function b. Well, let's just fill in what we found. We said that the y-intercept for function a is -3, and then the y-intercept for function b is -2. So let's reread that one more time. The y-intercept, so -3, is greater than -2. When you're asking yourself what number is greater, the way you need to think about this is which one is closer to the positive direction. In this case, the number that is closer to the positives is -2. So -2 is the one that is greater. The correct answer for this question is going to be the second option. The y-intercept of function a is less. -3 is less than -2. So in this case, your answer is the second one. Here you have two problems to see if you understood what we talked about in the previous slides. Notice that one of these is asking you to focus on slope, and the other one is asking you to focus on y-intercept. You have 30 seconds. If you need more time, press pause and resume when you're ready to start. Your time starts now. That was 30 seconds. Let's see how you did. For this first problem on the left, we're being asked to compare the slopes. The slope of function a compared to the slope of function b. To find the slope of function a, we remember that this is the same thing as looking for the change of y over the change of x. Slope, rate of change of y over change of x, they're all the same thing. We're going to start by finding 2 points. You could use this point, or 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 this point. There's a bunch of points that you could choose. It doesn't matter which 2 you choose, but you do need at least 2. I'm going to erase some of these and just focus on those 2 right here. To get from one point to the other, I just need to move up 1, 2, 3. Because I moved up, it's a +3, and then I move 1 to the right, which is a +1. This means that my change of y is 3 and my change of x is 1. 3 because I went up in the vertical direction, that's change of y, and 1 for change of x because I moved to the side. 3 divided by 1 is the same thing as saying 3, so my slope for function a is 3. To find the slope of function b, we might need to rewrite y equals mx plus b. We remember that m is our slope, so the number next to x is what our slope is going to be. But here we have an interesting situation. In front of x, there is no number, but there is. It's not a 0. Whenever you have a variable by itself, there is technically an invisible 1 in front of it. So here, our slope is actually equal to 1. So now the question is, which of these is greater? Is the slope of function a greater than b, or the other way around? Slope of function a is 3. The slope of function b is 1. Is 3 greater than 1, or is it less than 1? In this case, it is greater, which means that the first option is correct. For the second problem, we are being asked to compare the y-intercepts for both of these functions. For function a, we have y is equal to 3x. So if we look over here at slope-intercept form, we know that b is the y-intercept. So it's the number that's at the end, after the x, after the m. It's whatever number is at the end. For function a, there's nothing at the end, but there is technically a number there, and it's not a 1 this time. This is the same thing as saying plus 0. In this case, our y-intercept is 0. So I'm going to write down b is equal to 0 because b is what we use as our y-intercept. For function b, the y-intercept is a little easier to find. It's right here. It's where my line crosses the y-axis, and here it crosses at -2. So b is equal to -2 for function b. So which is greater? Is 0 greater than -2, or is 0 less than -2? Again, whichever number is closer to the positives is the greater number. In this case, 0 is the greater number. The y-intercept of function A is greater than the y-intercept of function B. So here, the first option is correct. What you see in front of you is the third type of example that you're going to see as you work with these problems. So we're not focused on y-intercept this time, we're not focused on slope, but instead, if you look at the question, we're being asked to compare the y value of a function when x is equal to -1. So what is the y value of function A when x is equal to -1? And what is the y value of function B when x is equal to -1? To truly understand what this question is asking, we need to remember a very specific detail. We are talking about functions, which means that we're talking about relations. There is a relationship between x and y. Together, they make up points and coordinates. So this is what I mean. Again, we're talking about x and y values. So we have x's and y's. And yes, we think about this as a point, but we could also think about this in relation to an equation like in function b. For this problem, we're being told what x is equal to. Here we're being told that x is equal to -1, but we don't know what y is equal to. So let's look at a function a. How would we find y if we know what x is equal to? Let's just start off by finding where x is equal to -1 for function a. So here we have our x-axis going side to side. -1 is down here. So this is where x is equal to -1. So now that I moved to the left one, to -1, now I need to find what y is equal to. Well, when x is -1, y, if you go down here, is -4. You could write this as a point. You could write this as a coordinate. I'm just going to write it right here because it's just some empty space. But when x is -1, y is -4. So remember, this is just x and this is y. So this is our answer for function A. We're going to be doing something very similar for function B, but we're going to find y in a very different way. What we're going to have to do for function B is substitute or plug in what we are being told x is equal to. So let's look at function B. We're going to be plugging in the -1 into this function. This is what I mean. Instead of writing y is equal to 5x minus 3, I'm going to write y is equal to 5, but instead of writing x, I'm going to plug in what x is equal to. And in this case, x is equal to -1. Now that I know that x is equal to -1, all I have to do is simplify, figure out what y is equal to. In order to do that, all we have to do is follow the order of operations. In this case, the first thing that I can do is going to be to multiply, because I see a number next to a parentheses, and that automatically means multiplication. So 5 times -1 is -5. I'm going to bring down the -3, and all of this is still equal to y. The next thing, what is -5 minus 3? -5 minus 3 is -8. So here we have y is equal to -8. So this means that when x is -1, y is -8. So this is what we were looking for function b, -8. So now let's look back at the question. Which of these values for y is greater? We said that the y value for function a is -4, so -4 right here. We said that the y value for function b was -8, which is right here. So when we read the first option, it says -4, so the y value of function a, is greater than the y value of function b, which is -8. Is -4 greater than -8? Is -4 closer to 0? In this case, yes, -4 is greater. It is closer to 0, so it is our answer. Now it's your turn. Similar type of problem. You have 30 seconds, see how far you can get. If you need more time, press pause and then press play when you're ready to go. Your 30 seconds starts now. That is time. Let's review this problem together. For this question, we're being asked to figure out which of these is true. Again, the difference is that one is saying greater, the other one is saying less. More specifically, the first one is saying that the y value of function a when x is equal to 4 is greater than the y value of function b when x is equal to 4. The second one says less than. So let's figure out which one is correct. For function a, when x is equal to 4, okay, so x is side to side. So if x is equal to 4, so there's 4 right here. Let's find y. Y is going to be right here, which it looks like it's going to be a 7. Okay, so that means that when x is 4, y is 7. So that's my y value for function a. For function b, we're doing it a slightly different way, but similar as the previous problem we did. We know what x is equal to. So let's go ahead and write this equation. Y is equal to 3, but instead of x, since we know that x is equal to 4, we're going to go ahead and plug it into that equation. Now let's figure out what this is equal to by simplifying. Let's start off by multiplying 3 times 4. Well, that's 12. Everything else stays the same, minus 2. All of this is equal to y. And then 12 minus 2, that gives us 10. So y is equal to 10. That means that when x is 4, y is equal to 10. So we're comparing 7 and 10. Which of these two is greater? Well, 10 is greater. So that means that the y value for function a is less than the y value of function b, because 7 is less than 10. So the second option is your correct answer here. Now let's take everything that we just did and talk about what it would look like when we introduce fractions into some of these problems. Here's example number 4. It's going to be very similar to what we just did, except that we're going to be focusing on fractions. For this specific problem, we're being asked which of these two statements is true, just like before. But this time we're going to be focusing on slope. So is the slope of function a greater than the slope of function b, or is it going to be less? Let's figure that out. Function a is just an equation written in slope-intercept form, so we have y equals mx plus b, in case we need that reminder. We know that the slope is m, whatever number is being multiplied by x, so in this case our m is going to be 1/2. So our slope, our m, is just 1/2. We found that. That's it. Let's do the same thing for function b. Again, we need to find any 2 points. It doesn't matter which 2 points they are, as long as they cross at one of those intersections. I'm going to choose this point right here, and it looks like this point would also work. You could have also chosen this point, or you could have chosen this point, or you could have chosen this point. All of those would have been okay too. But I'm going to focus on the first two that I marked right here. Again, when we're looking for a slope here, it's the same thing as saying the change of y over the change of x. So let's go from one point to another. Let's start at our first one at our y-intercept, and we're going to move up 2. Because I moved up, it's going to be a positive 2, and then 1, 2, 3, 4, 5. So that is a positive 5. That means that my change of y is 2, my change of x is 5. 2 over 5. The main difference between this problem and the ones that we did before is that these two fractions cannot be simplified. They're just fractions. The first one, function a, is 1 over 2, 1/2, and then the second one is 2 over 5. So which one is bigger? There's a few different ways that we could figure this out. We could just try to compare these fractions as fractions and just maybe change them, create some equivalent fractions, but that might take a little too long. This is where your calculator will come in handy if you want to do this the fastest way possible. Some of you might be able to convert some of these fractions into decimals in your head, but in case you can't, let's just use our calculator. Type in 1/2 into a calculator to turn that into a decimal. That's the same thing as saying 0.5. And then 2 over 5, if you put that into a decimal, that's going to be 0.4. So which of these two slopes is greater? In this case, 0.5 is greater. So function a has a greater slope, which means that the first option is correct. The slope of function a, which is 0.5, is greater than the slope of function b, which is 0.4. Here's example number 5. This is another example of when you're going to have to use fractions, but this time it's going to be with finding the y value. And for this specific problem, we are finding the y value for function a and b when x is equal to 3. And again, we're trying to figure out which one is greater, a or b. Is it greater or less than in comparison? As a reminder, when we're looking at function a, we're technically just thinking about a coordinate. Same thing for function b, but it's a little easier for function a since we are talking about graphs. We already know that x is equal to 3. We don't know what y is equal to, but let's just go ahead and find that out real quick. If we go over to positive 3, remember that's x, it's 3. Now let's just go down and find out what y is equal to. It looks like y is equal to negative 3. So here, when x is equal to 3, y is equal to negative 3. That's our answer for function a. And just like before, for function b, we're just going to rewrite the equation, y is equal to 1/3. But instead of writing in x, we know what x is equal to. We're going to plug in a 3 into that equation. And then everything else stays the same. Just like before, all we're trying to do here is simplify. So let's go ahead and multiply 1/3 times 3. If you don't remember how to do that, let me do this on the side right here. 1/3 times 3. Because one of them is a fraction and the other one is a whole number, we want to create two fractions. We want both of them to be fractions, so we could actually work with them. In order to make 3 into a fraction, we're just going to put that number over 1. Any whole number divided by 1 becomes a fraction. And if you remember to multiply fractions, all you have to do is multiply straight across. So 1 times 3 and 3 times 1. 3 times 1 is 3, 3 times 1 is 3. 3 divided by 3, if you simplify that out, is just 1. So 1/3 times 3 is just 1. Next, we bring everything else down. So we have a minus 3, and all of this is equal to y. The next thing we're going to do is just subtract 1 minus 3, which gives us an answer of y is equal to 2. That means that when x is equal to 3, for function b, y is equal to 2. So 2 is the answer for function b. And last but not least, let's compare our two answers. We have negative 3 and 2. Is negative 3 greater than 2, or is negative 3 less than 2? The number that's closer to the positives is function b, is 2, which means that the second answer is correct right here. The y value of function a, which is negative 3, is less than the y value of function b, which was 2. All right, this is kind of like the halfway point. I would actually recommend that if you already watched the rest of the video before, you actually pause and work on the first IXL assignment. I will be adding your scores up to give you your final grade based on this table. If you have any questions about that, please let me know. Have a good rest of your day. I'll see you all later. Take care.